Hi everyone. Today I am going to discuss about one of the very important topic in piping design, which is pipe routing. Why did I choose to speak about pipe routing? Because in a broad scale, if you look at all piping designing activities, pipe routing is one of the major activity for any piping designing projects. Roughly I could say it holds nearly around 50 to 60% of your piping designing activities is only pipe routing. But there are different dimensions of routing. That is why we generally focus more on to the pipe routing. So it is not only about routing with respect to one particular parameter. The different dimensions in the aspect of different parameters. So there are safety factors, there are maintenance factors, accessibility. There are different aspects that we have to analyze the routing. Only then you will be able to finalize the pipe routing. So that's why I thought that better to have one particular video that gives you a very clear picture of what is pipe routing is about. Because most of the beginners or the people who doesn't get an opportunity to experience different dimensions of the pipe routing never understand about what is the pipe routing is all about. So this video will help you to understand what is pipe routing and what are the different dimensions and what are the different parameters based on which the pipe routing is finalized. So without wasting your time, let's begin. At first, let me start with one of the very important factor by which pipe routing is generally finalized, which is a process factor. The process designs the processing systems and the lines and fluid mechanics, and it is drafted in P&ID. So generally, the main purpose of pipe routing is to establish a piping arrangement that can facilitate the process requirements, that can facilitate the fluid movement. So only by facilitating certain fluid movement, they will be able to achieve certain operations and the byproducts. So one of the primary intention of the pipe routing is to facilitate the process requirements. So for that, one should have a strong knowledge in the P&ID. See, being a piping design engineer, if you do not know P&ID reading and if you don't have an ability to understand the fluid flow and the equipment connections with the different lines and how the lines are being plotted in the P&ID, then you may not be able to fulfill the piping design requirements. So the first and foremost thing for any piping design engineer is to understand the P&ID. You should not required to design the P&ID, so that will be taken care by the process engineers. However, you should be in a condition to read the P&ID flawlessly. So that is very much important for any piping design engineering activities. So the first parameter is that satisfying the process requirement. Let me just give you one particular example. If in P&ID there is something known as a gravity flow where the slope requirements are met. So for an example, what is slope? Slope is basically a line from the higher point and goes to the lower point. So this is known as a gravity requirement, which is indicated with slope. But if you, in reality, while planning your line designing, if you change the elevation of these 2 points, there will not be any flow. So there is no flow happening in this particular line. Instead, there will be a reverse flow, and that consequences is different. So that's one of the reasons why P&ID reading and understanding is very much important for a piping design engineering. So this is the first point based on which the pipe routing is finalized. The second important factor is the overall space. See, when you are routing a line in a particular plant or for any purpose, so you have to utilize the space effectively. So let me give you some example. Let's take our home as an example. Do you think that do we arrange the furnitures in such a way that we block all the spaces in the house? No, right? How do we arrange and how do we utilize the space in the home? It works in the same fashion, but it will have a little more stringent requirement because of the lots of other safety concerns in the plant basically. So we generally used to arrange the equipment in particular place so that the other space can be utilized perfectly, right? So this space utilization is one of the primary factor for any pipe routing. We cannot simply route the line in the middle of the plot. We have to see how we can route a line in such a way that the minimum space is utilized and the maximum space is left over for future development. So that is one of the primary requirements. So Space utilization is the second most important point based on which the pipe routing is considered. So in order to understand about the space utilization, one should have a little bit knowledge about the layouting part as well. Because see, if you route one particular line, you might not consider several factors. But imagine that if you had to route 100 lines, then you really have to consider the space utilization, because randomly you cannot put lines everywhere, right? So this will occupy the entire plot and it will cause a lot of other troubles as well. So space utilization, it's also related with the layout plan. So this is the second most important factor. If you are a candidate looking for a piping design course to improve your design skills, you can refer my website pymedaca.com. I will give the link in the description of this video, where I have listed 3 primary courses. These 3 main courses are intended to develop the primary piping design skill. One for P&ID and one for pipe routing, and the third for pipe supports. 3 courses are individually different courses, are intended to develop a specific piping design skills. The skills that these courses are going to give you are the primary design skills that every piping design engineer should possess. By taking this course, you will be able to perform better in the interview. You will have more clarity about the knowledge. You will have a better vision in your day-to-day activities, so that you will be able to perform better in your current working job. So that is the very intention of this course. Moreover, the primary intention of this course is to give you the understanding of engineering principles, guidelines, philosophies and theories and the methods in order to finalize your design. Basically, by completing this course, you will be able to understand how to design. Moreover, I would like to happily announce that there is 50% flat discount for those who are buying 3 courses together, by which you will be able to save at least around 9,000 Indian rupees. Please avail this offer as earliest before April 15th, because the end of offer is on April 15th. Avail this offer at the discounted price so that you can buy these courses at a cheaper rate to improve your knowledge, so that you will be able to perform better in the interviews and as well as in your day-to-day activities in your current job. And the third most important factor is the cost. So how do you reduce the cost actually? Simply saying, you can reduce the cost by minimizing the materials. So how do you minimize the material is one of the discussing topic actually. So you can minimize the materials in different fashion by minimizing the number of fittings, number of the length of the pipes and number of supports. By reducing number of supports, your foundation gets reduced, your structural requirement gets reduced. So it has a direct connection with the cost actually. More the materials, more the cost. For example, in a line, if it is badly designed, you can put 10 to 12 elbows randomly without any purpose. But if it is designed with the right parameters and the right technical recommendations, you can design only with the 3 or 4 elbows. So you will be saving nearly around 6 to 8 elbows. This is one of the major cost factor. And if you add more materials, there is another factor also getting added, which is a welding. So more materials has to be welded, because piping is all of metals, right? So only few pipings are in the PVCs and other materials. Most of the piping materials are in metallic. So metallic piping needs to weld. So more the materials you add, more welding will come. Remember, cost of the welding is too much compared to any other components or any other activities in the piping, because the welding procedure itself is a more stringent procedure. So that requires a lot of the qualifications, testings and implementations and everything. So more the material directly increases your cost. Cost not only in terms of minor variations, sometimes there are costs that will stop the entire projects. So it's better one should analyze these factors and design the line accordingly. You might think that this may be a couple of items, it will not cause any major escalations in the cost. But if you compare this small escalations in multiple lines, then the huge amount, the variation will be a huge amount. So this is another important factor that plays a crucial role in finalizing the pipe routing. Now let's come to the next one, is the accessibility and maintenance point of view and constructability as well. So what is this accessibility, maintenance and construction? See, when you are designing some line, you should design in such a way that it needs to be accessed, it needs to be operated, it needs to be constructed, right? For example, you're designing a line, without seeing a nearby line which has a valve and instruments on it. So you are designed a line right in front of the nearby line, so you have blocked the entire accessible space for the nearby line. So in this case, it is purely evident that the accessibility for that particular line is not considered for designing the new line. So when it comes to accessibility and maintenance and operations and constructability, we have to see in all aspects, actually, all aspects in the sense, you have to see whether any equipments are there in the plant which needs regular maintenance, whether your piping is causing any hindrance to this equipment maintenance, whether your line is properly designed for the construction or not, because in most of the design we used to give field well. Field well is generally provided in order to limit the length of fabrication, because there are some constraints in transporting the higher length of pipings in the trucks basically. So field wells are conveniently provided considering some aspects of constructions as well. So all these factors comes into play. Accessibility, everything needs to be accessible, right from valves and instruments and whatever items that needs a regular maintenance and regular monitoring, it's required to have a good access actually. Then maintenance, any equipments or any instruments or any valves which reach regular maintenance, that provision needs to be available. You need to provide a certain platform and everything, only then it will be accepted by the design actually. Then operability, you have to see whether you have enough provided enough access for operability. Maybe your line is not blocking any access, but the valves are not in the operable height, valves are doesn't have any the operable platforms and construction. All these factors that you have to consider. So this considering all these factors, it's not an easy task. One should have a proper understanding about this accessibility, maintenance and everything. So generally in working experience, by regularly cooperating with your seniors and coordinating with multiple other requirements in the design, you will be able to understand the visibility of this requirement, so by which you will be able to make the pipe routing well considering all these factors. So this is one of the key factors by which the pipe routing is also finalized. And the last but not least is the safety. See, whatever things that we do in design is also should ease safety. Safety for people who are working in the plant, safety for construction, safety for the operators who have to regularly go and operate the valves and instruments and everything. Let me just give you one example. See, if you route any particular line in the accessible walkway, which is at the elevation of nearly 300 to 500 mm, without providing any crossover, so there are chances that the person or operator, whoever works or whoever pass through that particular lines, may get tripped and may fall down. If it is in the higher elevation, you can imagine the impact of falling actually. So safety is a primary concern. As a design engineer, naturally we should have this thought. So that's one of the biggest role for design engineer. So you are not designing just for the sake of completing a particular line or particular activity or nothing. You are a design engineer. You should have a thought process in such a way that my system is designed in such a way that it has considered all other factors. So whatever factors that I have seen, that all has been considered and designed accordingly. So that confidence you need to have. For that, you should have a lot of focus, a lot of involvement, a lot of understanding about the requirements actually. So safety is a vital concern, because you might have came across a lot of news, and if you just Google it, you will be able to find it. Because of the poor designs, there are a lot of people have lost their lives. So it is not only about some infrastructure damage, it is about losing a people. So it is not at all a reversible process. See, if there is a minor damage about the infrastructures, it can be reversible, but losing a people is a huge loss actually. So your single mistake can drastically impact the other's life. So it is very important to consider the safety aspects. So these are the primary aspects of the finalizing the pipe routing. So I believe that this video has helped you to understand the basics of pipe routing. I will meet you in another fantastic video. Until then, bye from Subhash Chandra.